All right, well, we'll give this a shot for part number 2. On the previous part, it cut me off at number 18. So in part 2, I hope we're going to get some more things done, and we'll go a little bit further than just the first 18 problems. So starting with number 19 for part number 2, anything raised to a multi-angle is definitely going to end up being a rose shape. Since the multi-angle is negative, this is ultimately going to be a rose with 7 petals. P-E-T, petals. And ultimately, it's going to be in a sine direction going positively. And ultimately, on these particular questions, probably your best bet would be to probably put your calculator into polar and ultimately put it into, I believe, degree mode. So I'm going to put this one in here so you can see kind of what the shape would end up looking like. Right now I'm in the wrong mode there. Let's put this guy in polar. And then I'm going to go to my y equals and put that value in. So it's going to be 6 sine of 7 theta. And let's see what kind of picture it makes. It's probably going to make a scrambled thing like this right out of the gate, but it does give you some insight to which direction the actual petals should be going. In this case, they're going down and ultimately separated in that particular regard. The angle of incidence would be 7 into 360 degrees, and that would give you that angle of incidence between the angles. If you want a really better picture, I think you have to either zoom standard. No, that ain't going to get the job done. It might be a zoom trig, and I don't think it likes that one very well either. So I can't remember how to set this window on this one, so I think it kind of gives you some insight, but it doesn't give you the best picture that you could hope for. I don't have a lot of time to play around with that right now. Find the polar equation of the following graph. We've definitely got one that's got a loop here. The loop's size is 2. The diameter of such is 8, and it's going in a downwards direction. So I definitely know that this is going to be a sine theta concept. And if I'm going to make it end up having a loop, there's going to be a smaller number up front and a bigger number in the back. So ultimately, something that has a difference of 2 but has a sum of 8, that'd be a 5 and a 3. So it'd be 3 minus 5 sine theta. I'm going to check that to make sure I got that one right too as well. Number 20. Let's zoom down here to the bottom. And that's a lemison with an inner loop. That's all it ends up saying. 20. 3 minus 5 sine theta. Ooh, I got it right. Okay. Answers to questions up above here, ultimately, ones that you really want to check to decide how many triangles they end up forming is definitely going to be your angle side varieties. We'll talk about that guy in just a second. But anything that's angle side angle is definitely going to be 1. Side angle side would be 1. Anything that's obtuse, the only thing you'd have to worry about here is that the obtuse angle is across from the longest side, and if that's the case, then you're definitely dealing with 1. Any of the ones that fall into the angle side, you're going to want to draw your dangling side and find the individual height. This angle is 26 degrees, and the opposite side is 15, and this is 32. Okay, now to find that height, you do the adjacent sine the angle, and let's find out what size that turns out to be. Come on over here. Betsy, let's find out what that answer is. That's 32 sine of 26. And that angle size is 14.0. Now, here's the thing about that. We've got 32 sine 26. I'm thinking that should be correct. It is definitely going to exceed the actual 14. So it is going to make a triangle, but it also will fit in between these two. So this would be 2 triangles. And we can check that answer down here, number 21, and make sure that we did that right. 21 says 2 triangles. Look at you, G. You're doing pretty good today. All right. Okay. Finding the polar form for a rectangular imaginary. Well, the key here is you got to find an r and you got to find a theta. R is going to be found by using the Pythagorean theorem. So the square root of 5 squared plus negative 3 quantity squared. It's going to be 25 plus 9, which is the square root of 34. There's your r. That's not too bad. Theta, on the other hand, is going to be calculated by finding the inverse tangent of 5 divided by negative 3. And keep in mind that tangent inverse only exists in the first and the fourth, and this guy here is in the fourth, so that's actually a pretty good deal. Let's find the inverse tan of that. My mode is in degrees, so that's going to be okay. Inverse tan of 5 divided by negative 3 is going to report an answer that is in the fourth quadrant, but it's going to be negative. Now, I don't think they're going to like that cis formula being written with a negative, so it'll be square root of 34 cis of, now this in positive terms, if I added 360 to it, 360, and I would get 300.9 degrees. And that would be your answer. 301, close enough, okay? Going back to rectangular, you would want to just do some distribution. This is cosine of negative 105 plus sine, I sine of negative 105. And ultimately, you would distribute this value on each one of these two and just evaluate them. So relatively easy question here. 240 cosine of negative 105. And that answer is going to give us negative 62.1. And if I take that same entry and I tack a sine value in it, I would see that we're probably dealing with negative 231.8 I. And we could think of that as subtraction. Now, key thing here is negative 105 is in the third quadrant, and this is negative and negative. That's in the third quadrant too. Make sure that you coincide with the same given location. Multiplying polar imaginaries is pretty straightforward. You end up multiplying the outsides, and you end up adding the angles. So this answer would be half of 28, which is 14, cis of 8 plus 22, which is 30 degrees. Pretty straightforward. Dividing them works pretty much the same way. You divide the outside pieces and you subtract the actual angles. 3 divided by 0.04, cis of 95 minus, I think that's 43 degrees. And I believe that answer is 75. I've done that one a couple of times, and I think that's the right answer. All right, going down here to these vector questions. The one thing that I will say was missing on the actual video itself was definitely de Moivre's theorem, and that boils down to how to use a power on a cis. So if I had 12 cis of, say, 25 degrees, and I raise that to the third power, it actually raises the front to a power, but at the same time, it multiplies this guy on the inside. So it'd be 12 to the third cis of 75 degrees. So be careful of that. Make sure you know how to use de Moivre's just as easily as you know how to do multiplication or division. Vectors, these relatively, I say vector, oh yeah, we can do them. Vectors end up dealing with, maybe if we have to apply a negative, so we'll apply it through it, negative 7i plus 3j. All I'm doing is applying a negative through a. A multiplier, scalar multipliers work pretty much the same kind of way, except you just multiply through, plus 3j. And then a negative through that one would be a positive 10i plus 2j, and you would just combine like terms. Pretty straightforward. Dot products. Dot products, well, 7i minus 3j is another name for a. That's this guy right here. B minus c, which we'll do in our head up here on the top. So I'm going to take this one minus that one. That would be 6i. And that would be negative, positive 3j. And then if I do a dot product, you multiply the x's and you multiply the y's, and then you add the two together. So this would be 42 plus negative 9, and that answer is 33. Keep in mind that when you do a dot product, you get a scalar as an answer. Key things to remember is that if you get an answer is equal to 0, it just means that the two vectors are perpendicular. Orthogonal is the word that they would use. Finding a magnitude of a vector, this is very similar to the question that you saw up above, but ultimately, once you ended up getting that vector, whatever it happens to be, you would find its magnitude of that vector would be the square root of a squared plus b squared. And we did this so many times that that should be pretty automatic at this point in time. Number 31, we're cooking through this. And I'm sorry I'm not doing every single question. I think ultimately a little explanation kind of gives away what the question is asking for. 31 does a really good job of using full-size angles, so ultimately we don't have to worry about the dimensions, the signs on those individual dimensions. We can just set them up. Excuse me. Cosine of 33 degrees, I, plus 240. Sine of 33 degrees, j. That's first vector. Second vector would be 180. Cosine of 282, I, plus 180 sine of 282, j. Big old fat line. Add those vectors together. Get a resultant force. Not with a dollar sign on it. And this is what it would end up looking like. So I'm going to plug one of these out. This is a pretty basic, straightforward vector question. 240 cosine of 33. And that would be added to 180 cosine of 282. And probably at a good time like this, I would store this as alpha A. And that answer is 238.7. I'm storing them because I'm going to use them later to calculate the magnitude and direction. Second entry, bring this bad boy back down here. I'm going to alpha B this time. But this time around, instead of using cosines, I'm going to use sines. I'm just a kind of a lazy person here, so I don't like to type everything all over again. And that answer is negative 45.3J. Now, ultimately, the answer is in a positive, negative, or fourth quadrant, so you want to make sure you pay attention to that. And let's see if we can get the actual magnitude of that resultant vector, and we would do the square root of a squared plus b squared. Square root of alpha a squared plus alpha b squared. Answer 242. I think this would be in pounds. 0.9 pounds. You're going to get awfully close. 243. And the direction, this is the one you got to be a little tenuous about. Just make sure that your direction makes sense based on where your vector is located. The inverse tangent of alpha b divided by alpha a. And I'd get negative 10.75 degrees. Now, be careful. That is in the fourth quadrant, but since they're dealing with full angles, I think they'd probably want that angle expressed as a positive, which would be 349.24 degrees. And that would be definitely in fourth quadrant. Now, if it happens that your vector problem is not in full angle size, they may actually be in, bearings. Make sure you know how to do that. Some that's going due south has no I, but it has negative 420J, so that's a relatively easy one to do. The wind is blowing at 24 degrees to the east at 72 miles per hour. Again, that's in a positive zone, so I don't have to really worry about that part of it, but I cannot use the 24 degrees because it's a bearing. I have to use its reference angle, which would be 66 degrees plus 72 cosine of 66 degrees J. End up adding those two together, get the resultant vector, and get the true ground speed, which is resultant, and the direction of the actual plane. Same as number 31, just a little bit set up differently. Number 33 is a backwards working question, and I would doubt anything even of the sort would be on the actual final exam. That question is pretty saucy, and you should probably go back and take a look at it if you plan on taking physics someday. Partial fraction decomposition. These are relatively easy questions once they're already set up for you. Look at that. How nice. They're distinctly real answers. That's why they set them up as a over x plus 1 and x plus 2. If you multiplied by the denominator on the left-hand side, you'd end up with just x plus 4 is equal to. And if you multiplied by this side, it distributes partially, but it doesn't cancel it fully. So this would be a times x plus 2 and b times x plus 1. You only get a partial cancellation there. Now a little distribution here, ax plus 2a plus bx plus 1b. Combining like ideas like x together, and I'd end up with a plus b right here. And the constant terms would be 2a plus 1b. And now you can write your two individual equations, which would be a plus b is equal to 1 because of the coefficient in the front here. And 2a plus b would be equal to 4. Now, ultimately, I think maybe solving that one would be probably easier with a little bit of elimination, and I think you probably could figure it out from there. Let's go to the second guy over here, because at least we can talk about this one being done with matrices. 8x squared plus x minus 17 is equal to a times the idea that it's not going to cancel, which is x squared minus 3. And that's going to be added to bx plus c times, and I'm running out of space there, G. Come on, move it over. Times x plus 1. Now, a little distribution is going to take place here. Ax squared minus 3a plus, this is going to be double distributed, so that's bx squared plus bx plus cx plus c. Putting things together that seem like ideas, that's a plus b for the x squared part, and x times bx b plus c, plus the constant term, which is negative 3a plus c. Now, you got three equations this time around, and those three equations would be a plus b is equal to 8, b plus c is equal to 1, and negative 3a plus c would be equal to negative 17. Now, this is probably worthwhile to actually throw into a matrix concepts, three equations, three unknowns. Just pay attention to actually how I plug this in, because that will matter to you. It will be a 3x4 matrix. This would be 1, 1, 0, and 8. Now, the reason for that is because the c is missing in that first line. In the second line, it'd be a 0, 1, 1, and a 1. And then down here on the bottom, negative 3, 0, 1, and negative 17. Oh, looks like they've done this problem before. Now, once you get that matrix C in, you're going to want to do some math on it. That's where you're going to go to the RREF under the math menu, and you're going to do a second matrix, paste the name of it inside, and that'll give you the three answers you're searching for, which are that A is 5, B is 3, and C is negative 2, and you can plug those back right into the equation. Now, I don't know if we did a lot of the solving system stuff right here. I think this might have been a section that we did get a chance to skip. We skipped this year because of COVID. Ultimately, there's really only two ways to solve these systems of equations, and that, three ways: substitution, elimination, or matrices. This right here is a dead giveaway matrix question. That's three lines in three-dimensional space, all intersecting each other. And this one is a circle being crossed by a line, which would mean that it has two solutions. And I think the easiest way to do this one would be to plug that inside there and solve for y squared. Now you end up with 5y squared is equal to 5. Trust me, and you divide by 5, you get y squared is equal to 1. Or y is equal to plus or minus 1, because you took the square root. Plug that back in here, and you're going to actually generate two answers for x, and ultimately 2 points where they cross. Moving down to conics. One of my favorite sections is definitely got to be conics. I love the ellipse, the hyperbola, and the parabola. Ellipse formulas, especially the ellipse equation, I'd be starting to think that that's a plus and a equals 1 concept. Maybe some other things that are in the background, maybe a squared minus b squared is equal to c squared because we're talking about an ellipse. And I'd also be thinking that the a squared is the big one. All right, those are kind of like the 3 things to remember when it comes to ellipses. Let's see if we can put this guy back together. That coordinate is -2, 3. So my equation would be x plus 2 quantity squared plus y minus 3 quantity squared equals 1. They go back as opposites because they're h's and k's. And then the bigger answer for the major axis is 4 right here. So that means the 16's got to be in the x direction. And this guy's going to be 4 because the minor axis is 2. There's your equation. Okay? Practice that kind of equation making in number 38B, and you might get good at it. Woohoo! All right. Length of the major axis in 39A is definitely looking for 2A. Well, that one is the a squared, or a is equal to 7. So 2a would be equal to 14. Well, that's a pretty easy question. Solve that in less than 30 seconds. Distance between the foci. Well, you can actually locate the foci. Foci are all about C. So I'm thinking that must be 22 plus 14 for a squared. Oop, not plus. That should be minus. Oops, one more. Minus 14 is equal to c squared because the Pythagorean theorem is a subtraction. That'd be 12 is equal to c squared, or c is equal to 2 root 3. And if I'm trying to find the total distance between the two c values, I'd be probably finding 2c, which would be 2c, 4 root 3. That's the answer. So think about these things. I think you got this under control. Ellipses, vertices are always going to give you A concepts. Foci are going to give you C's. Minor axis is 2B. Looks like a Pythagorean theorem concept. 16 minus 4 is equal to, oops, that's wrong. 16 minus b squared, is equal to 4. Subtract, I'd get b squared is equal to 12, and b would be equal to 2 root 3. And the full minor axis would be double that, which is 4 root 3. I'm checking my work there. Did I do that right? Yep, I feel like I did it. Okay, dokie. Moving down here to number 41. Ellipse with co-vertices, that's B is 6. Foci are C, that's 5. Find the major axis, that's 2A. Cha-ching, your turn. Get her done. 42A. Equation of a parabola graphed at the following is at the right. Okay, so this parabola is going in a y direction and it's going down. Now, that's important information. It does have a vertex of 2 and -1. More information that's great. And its p-value is -2. Now, how are you going to put all that stuff back into the equation? Now, first off, I say it's going in a y direction because when you put the formula together, the y direction tells you which one should be unsquared. So the y piece is unsquared and the x piece is squared. That's going to help you in that particular regard. Now, it also turns out that the 4p value is going to go out here in the front, and this is going to be minus k, and that's going to be minus h. Oops, h. So let's put this guy back together. Y minus k, which would be plus 1, is equal to x minus 2, quantity squared. And since p is -2, this would be -8. And that's how you write a parabola. So get that important information. Direction, vertex, and p. That'll help you. On these kind of questions where they give you a point or they give you directrix stuff, best thing you can do is probably draw a picture. This is the vertex. Directrix is 1, 2, 3, 4, 5, way the heck over here. That would mean the focus is out there, and whoop, that's where the parabola is going that way. So it's going right, which is an x direction. The p-value in this case would be to +8, because that's the same distance between the vertex and the directrix, and the vertex is at 3 and -2. Now, let's piece it together. Going in an x direction must be x's unsquared. X minus 3 quantity, equal to y plus 2, quantity squared, and the actual 4p would mean that that's 32. All right, practice some parabolas. They're the ones that I think are the hardest ones to remember, but not too bad. Foci of a hyperbola means you're probably looking for c. Hyperbolas have a squared plus b squared equals c squared. They have a positive Pythagorean theorem. And ultimately, that's a squared is first. That's another thing to remember with hyperbolas. 81 plus 23 is equal to c squared. And ultimately, you get the square root of 104 is equal to c. Now, the question is, where should I add them onto? The center is at 0, 0. And since this hyperbola goes in a left-right combination, I should add it to the 0 or to the x part, which would mean that the foci are plus or minus the square root of 104, 0. That's where they're at, adding them to the x because they go in the same direction as the hyperbola. This question, since y comes first, that hyperbola goes up and down. So that's a little tiny bit different. That's still a squared. C is going to end up being 64 plus 10, which is 674. Square root of 74. 74. And the center is at 0 and 1. Now, be careful with that. That is backwards because that's h, that's k. And I would want the foci to be added to the y part of the actual deal. So plus or minus the square root of 74. 44a, find the vertices of the hyperbola. Vertices of the hyperbola are going to be about a. So we would add that to the center. The center is awesome. That's a 0, 0 center. So the vertices would be an a amount added on to the x direction, because this is going in an x direction, hyperbola. And if I added on 11, I think they'd be at 0. Oops, not 0. They'd be 11, 0 and negative 11, 0. That would be your vertices. Find 44b, do the same thing. See if you can do it. Parabola that has a focus at a certain spot and a directrix. Again, draw an equation. You're going to have a focus at negative 1, 2. And you're going to have a directrix that x equals 7. 1, 2, 3, 4, 5, 6, 7. Directrix like this. Somewhere halfway in between is going to be the vertex. So that is 8. So 1, 2, 3, 4. It's going to be right there is where the vertex is, which is at 3, 2. And now you can put the actual deal together. Goes to the left. It's going to have a negative p-value, which is p is negative 4 because it's going left. You piece that together. Get that equation going. And then try 45b. Equations that you might be looking for are on the formula sheet. Formula sheet has been added to Teams, so if you're interested in taking a look at that or previewing it, you absolutely can. There are several formulas in Chapter 10 that could be useful. Remember, the key here is to always ask the question, are you arithmetic or are you geometric or are you something else? And if you can answer that question, you can really get yourself going in the right direction. So that's being added 3. That's arithmetic. And the arithmetic formula is a sub n equals a sub 1 plus n minus 1 times d. And that'd be 7 plus 87 times 3. And cha-ching, bada bing, you get the answer. Same kind of idea. This one's going down by 4. Oop, you're arithmetic too. So that must be a sub 107 is equal to 30 plus 106 times negative 4. And you'd get the 107th term. Good job. You're doing good. Sums are where usually people struggle the most. Ultimately, they still forget that they're trying to do arithmetic or geometric. That's going down by negative 3/5. That's arithmetic. And the arithmetic sum formula for the first 55 terms is 55 divided by 2 times the first term, which is 7/5, plus the 55th term. So you got to do the 55th term on a separate problem. 7/5 plus 54 times negative 3/5. And I've actually done this problem. That's negative 31, which is bizarre. And then you can plug away and get that actual answer. 47b is still arithmetic. That question is going up by 2/11. And see if you can figure that one out. 48a, find the sum of an arithmetic series. That arithmetic series is the following. Now, before you even write that formula, what I shouldn't do, I should check to make sure that the rate works first. And if the rate is between 1 and negative 1, I can find that infinite series. But otherwise, the answer would be either positive or negative infinity. This is 6 divided by 8, which is how you find the rate. Or A2 divided by A1, that's 3/4. Ooh, we can do it. So this answer would be 8 divided by 1 minus 3/4, which is 8 divided by 1/4, and that answer is 32. Same kind of question going on in number 48b. Again, find your rate right out of the gate and make sure that that rate is working. It's geometric, and you divide one by the other. Make sure you come up with that rate and figure out how that sum's going to work out. Find this infinite sum. I am not sure whether or not we'll do these kind of questions on there, but the ultimate deal here is that if I take the 2 and divide, my rate would end up being of a sub 2 divided by a sub 1. I'd end up getting r. Now, since they said it's an infinite geometric series and it does add up to 60, I would have to assume that the ratio is going to be between 1 and negative 1, but I'm solving for it. And that would ultimately mean that on this side I'm going to get 60, and over here I'm going to get 4 over 1 minus the rate, which I have no idea it is. It's r, and then I'd cross multiply and solve. Okay? Pretty straightforward question once you actually set it up. Try that question on 49b and see if you can get it to work out. The first sum of the first 50 terms of an arithmetic sequence are listed as the following. They give you the common difference and they tell you what it's going to add up to. Whoa. So I know that 80 is equal to an arithmetic sequence, which is going to end up being 50 divided by 2 times the first term, a sub 1, and then it's going to be the last term. Well, the problem is I don't know what the last term or the first term is, so I have to find some way to simplify this. And a sub 50, this is going to be a sub 50 right here, is going to equal a sub 1 plus 49 times negative 3/2, because that's common difference, and n minus 1. And this entire piece right here can be substituted right there. And then you can solve it for a sub 1. This is an algebra problem. It's really not that bad. Give it a try. I think you could probably figure that one out. And then once you get it, try 50b just to try it on your own. See if you got it. Binomial theorem, or Pascal's triangle, to the 5th row of Pascal's triangle would be 1, 5, 10, 10, 5, 1. And that one's just one that I know. You've probably seen it enough times to know it too. So it'd be 1, x to the 5th, y to the 0, and then it'd be a 5, x to the 4th, y to the 1st, and then a 10, x to the 3rd, y to the 2nd, another 10, and x to the, go backwards, G. Going too fast. X to the 2nd, y to the 3rd, 5x to y to the 4th, and 1y to the 5th. Now, I got them all in there. That's a subtraction, so the signs would alternate as they go down. Minus, plus, minus, plus, minus. Done. Okay. Find the 6th term. Coming down to the 6th term, 12 choose 5. Now, that's probably the hardest part to remember right there, is that you've got to go 12 choose 0 first, and then it'd be 12 choose 5 would be the 6th term. Then it would be 2x and 3y raised to specific powers. This one's going to be 5 because it matches that one, and this would be 7 to get the balance of 12. And ultimately, these are all just numbers, and since it's the 6th term, even ones are negative. And I'm just going to remind you how to do 12 choose 5, and that is under math, probability, and n choose. So you got 12 choose 5 which would be 792. Now be careful. You're going to have to take 792 times 2 to the 7th and 3 to the 5th to get the coefficient that needs to go on there. And then watch how you write the coefficients on top of those variables. Cool. You got it. Writing a sigma for each one of the ones that are listed down below. That's sigma notation. Again, I think the best thing you can ask is it arithmetic or is it geometric? And if it's arithmetic or geometric, use the formulas that you've got on your paper. This is definitely going up by 3. So we've got an arithmetic. Sigma is going to go from I from 1 to 1, 2, 3, 4, 5, 6. And I'd put the actual formula right inside here, which is 6 plus n minus 1, or in this case, I minus 1 times the common difference of 3. Now, if that doesn't show up on your actual sheet, then just distribute this and simplify the answer, which would be 3i minus 3i plus 3. And that's the one that'll probably show up. Okay? If it's not, then they've done something with the extrema here on the sigma, and you have to look at, is it 0 to 5, or is it from 2 to 7? You have to look at which one generates your sequence. This one is multiple of 3, so this is geometric. And again, use the geometric formula to figure this out. That's from 1 to 4 because there's only 4 terms. First term is 2. The rate is 3 raised to the I minus 1. Now, a lot of people get all butthurt about this. You can put 0 and 3 here and just change that to I. It doesn't matter. Do not multiply 2 times 3 because it is not 6 as the base of that exponential. This guy's a factorial. Get that one kind of in your brain. That is I factorial. Sigma going from I is equal to 1 to 5. Pretty straightforward. This looks like 64 almost, and that looks like almost like 4. Oh, dude, this is just the squares minus 1. So x squared minus 1, and that sigma is going from, and I shouldn't have used x. Come on, G. Should be I squared minus 1, and that I is starting at 2, 2, 3, 4, 5, 6, 7, 8, 2 to 8. And then we'll get down to these factorial questions, which I don't think are really that bad. That's 32 times 31 times 30, blah, 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 blah. And this is 30 times blah, 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 blah. Cancel. Answer's 32 times 31. This one's 100 because the 99 cancels all the other garbage. This one actually has a little bit of fun to it. That'd be 3n times 3n minus 1, and then times 3n minus 2 down the road. And the bottom is 3n minus 2 already down the road, and those would cancel, and there is your answer. All right, we did it. 37 minutes I did for the second half. I am kicking butt and taking names. All right, good luck on the test, guys. And remember, it's 20 problems one day. It's 20 problems the other day. Stop freaking out and just show your teacher what you know. And you're going to be surprised. You really know way more than you give yourself credit.